Hey again, everybody. This is our final video of the week. This one's focusing on Ohm's law. So yet another physicist in our electricity topic whose name is named after a unit. Again, we talked about resistance yesterday. This guy is what the unit of resistance is named for, George Simon Ohm. He's the one who figured out that there was a ratio between the voltage through any conducting material and the current flowing through it. This is what he called the resistance of the material. And this ratio, when put into mathematical terms, is called Ohm's law. So here's a graph of voltage on the y-axis and current on the x-axis. If we were to draw a graph relating these two factors within any single part of a circuit, we would see a constant increasing line, a linear graph that is, and the slope of that line would be the resistance value. So any voltage divided by any current at the same point is the resistance of any object in a circuit. Just remember how you calculate slope. It's y-axis divided by x-axis. So the voltage divided by current will equal the resistance, and that's exactly what the equation for Ohm's law says. So there it is. Resistance is the voltage divided by current. You have this equation, as you do all equations I give you, on the reference table. And you can take a look up here. I've seen this before. Anytime there's a three-variable equation, you can set it up in a triangle like this, and any factor you're looking for tells you how to calculate with the other two factors. So for example, when we're looking for voltage, we take current and multiply it by resistance. If we're looking for current, we take voltage and divide out the resistance. If we're looking for resistance, we take the voltage and divide out the current. And so we have three different versions of our Ohm's law equation, each one solving for a different factor. Now, this is what you always wind up with when you're doing any mathematical equation. You just algebraically divide or multiply to obtain what you need. But here we already have the three versions of the equation set up for us. Again, keep in mind, resistors do have their resistance values change under varying temperatures. Typically, when temperature in a circuit goes up, the resistance increases, but we're always going to assume our circuits are at constant temperature, so we never have to worry about the R value changing on itself. Although in reality, there are some resistors that are called variable resistors, where you can manually adjust their resistance value to change the current coming into the circuit. And that's what's like a dimmer switch does. I'm sure many of you have either knobs or sliders on your light switches, and the lights can get brighter or dimmer. Well, that's a variable resistor. You turn the lever up and the lights get brighter. Well, you're actually decreasing the resistance then to allow more current into that light bulb, and therefore it glows brighter with more power. Anyway, we take a look at the units of our Ohm's law equation. Again, we'll take a look at the first version here. Resistance is voltage over current. Well, units for resistance is the ohm. Units for voltage is volts. And the units for current are amperes or amps. And by the way, I think I mentioned this before, the omega symbol, which is the abbreviation for the ohm, that is a Greek letter, omega. Again, it's just a nice convenience that George Simon Ohm's name matches a Greek letter pretty well. So we might as well name the unit after him that he discovered and use the symbol that already is established with the same pronunciation. So let's just take a look at one example of Ohm's law to get you ready for the exit ticket number 5. Let's say we have a current of 1 amp running through a lamp, and this lamp is connected to a 12-volt power source, and we want to find the resistance of the lamp. Well, we're looking for resistance, so let me just color in the words like I like to do. Current of 1 amp, that tells us our I value. 12 volts is our voltage. We're looking for resistance. So let's use the third version of the equation here. We're looking for R. Already tells us what to do. We take the voltage and divide out the current. So 12 over 0.1, that'll give us a resistance value of 120 volts per amp, or you could say 120 ohms. By the way, there is a simulation on the Fed website to play around with Ohm's law, as there is one for the resistance in a wire that I didn't mention in the last video. You can click them. They will work. I know we didn't have much luck on the last simulation for a lot of you, but I'm only using HTML file simulations from now on, so we never run into that problem. All the simulations I'll give you from for here on out will guarantee work as long as you can open up internet. Any device can run an HTML file format. But this simulation, as well as the one for the resistance in a wire, they're just fun ways to play with the factors within the equation to see what changes. Could be helpful. Spend 30 seconds on them. That's all you need. But otherwise, that's it for Ohm's law for now. This is the end of our first week of study of electric circuits. I'd like you to try exit ticket number 5, and I would also like you to tune in to our Kahoot games. We're going to run them at 12 p.m., 2 p.m., and 4 p.m. Take a look at Classroom. I will blast out a game code about 15 minutes before those 3 game start times. And I'm going to hit the play button at exactly 12, 2, and 4 p.m. So if you're not in, you could still join in with the game code, but you might miss the first couple questions. I'd like to see you all there for at least one of the rounds. Again, after this, you can go back and see if you can fill in any more terms in the term map, but we are certainly not done with the topic. We're only about halfway through. Next week is spring break, so you just enjoy your week off and stay well. I'll see you guys again in a while. Bye-bye and take care.